Hi everyone. State the integral test for convergence of series. Okay, so we consider a series. Now what's a series? A series is a sum of some sequence. Let's call them a sub n's, where maybe we're summing over the natural numbers, maybe we're summing over the positive numbers. I don't know. Let's take the positive numbers for now. Okay. So this is an infinite sum. And we want to know, does it converge? Does it converge? Does it diverge? Okay. Can we make sense of this? Well, the integral test can help us. If each a sub n is equal to f of n for some function f that's, well, at least hopefully defined on positive numbers, because we're going to plug in, either n or p, so that we can, plug in 3 and get out f of 3, and that f of 3 would be a sub 3. So we're interested in this thing, but if we can find that there's some function here, and if f is continuous, non-negative, what that means is that it takes non-negative values, so either 0 or a positive number. So actually I can just write that in the codomain of my map, the input space and the output space. Non-negative means that this part. Notice, non-negative does not actually mean this part, okay? Continuous, non-negative, and one more thing, decreasing. We will need decreasing as well. Yeah, basically we'll need decreasing because then we'll be always underneath the curve. Otherwise this would fail in the proof of this, but we're not going to prove it. Your book does. Okay, so wow. Am I correct? Let's reread this. Let's see how we're doing. We consider a series. Does it converge or diverge? Well, if each a sub n is just plugging into some function that's continuous, non-negative, and decreasing, then the integral from 1 to infinity of that function being finite implies that this thing converges. By the way, when I say being finite, other people would say that this converges. Okay, that's what I mean. In other words, this can be an actual number, a finite number like 123, okay, or 17.5. And if this integral diverges, and other people might say it gives an infinite number, or it just doesn't make sense at all, then this infinite series diverges. Okay. Let's look at that. If the a sub n's, the things we're summing, come from some function which is continuous, non-negative, and decreasing, then if we can figure out what the integral does, we know what our series does. Let's look in the book. The series converges if the improper integral converges. In other words, that's what I said, okay? The series diverges if the improper integral diverges. Okay. Good. This is the same. I just quizzed myself, and I think I got it right. One thing I will say, do you know what these words mean? How about decreasing? Well, that means that f of x should be smaller than f of y, if, well, it should decrease so if x is greater than y. Okay, this is one way to say decreasing. Non-negative means f of x is greater than or equal to 0 for all x, for all inputs. What about continuous? Interesting. When is a function continuous? F is continuous if it is, by the way, continuous is sometimes abbreviated CTS. CTS. Very useful. F is continuous if it is continuous at x for all x in the input space. Great, okay, so then what does this mean? Continuous at x. F is continuous at x. Let's say it's in the real numbers. If, well, if for all d there exists a delta such that x and y less than delta implies these things are less than d. What things? F of x and f of y are less than d. For all d being positive, there exists a delta being positive, such that if x and y are delta close, this is the Greek letter delta. If x and y are delta close, then the outputs are d close. For all d, there exists a delta such that if we're within delta of each other, then the outputs are within d of each other. So anyway, everything comes down to these epsilon delta limit definitions that we're learning. So it's a good thing that we're learning them. Yeah. You do not need to know this because it's not in our book. Not in